We're looking at the problem 17 here, particle in motion. We're given a position function for the particle. And the first thing we're asked is the particle speed increasing, decreasing, or staying the same initially here at t equals 0? So in order to answer that, we have to have a velocity equation, and we have to have an acceleration equation. So for the velocity, it's the derivative of our position. So it would be 12t squared minus 90t plus 150. For the acceleration, that's the derivative of velocity, which would be 24t minus 90. Okay? Now, when we want to talk about speed going up or going down, we can't just look at one or the other. We have to look at them both together and see how they interact. So our velocity at 0 is 150. That's a positive. Our acceleration at 0 is negative 90. That's a negative. Signs disagree. Okay? So because the signs disagree, our speed is decreasing. Decreasing. If the signs agree, even if they're both negative, as long as they agree, then we would be speeding up. We'd be either speeding up in a positive direction or a negative direction, but if they agree, we speed up. If we disagree, we're slowing down. Okay? And that's how we answer something like that. When does the particle change direction? So the only time that we can change direction is maybe when velocity is 0. Okay, so we have to find out when is our velocity 0. So let's take that velocity equation, let's set it equal to 0. So if I go this, and I'm going to go ahead and pull, let's say we pull, I think we can pull a 6 out of all of that. We'll have 2t squared minus 15t plus, looks like maybe 25. Looks like we have that. Okay, so that's pulling a 6 out of all three of those. All right, then we're going to try to factor what's left over. And what's left over, we got to have a 2t in there. So it's a little bit trickier factoring than maybe some other things. But what multiplies equal to 25? Negative 25, negative 1, negative 5, negative 5. If I try negative 5 and negative 5, outside would be negative 10, inside negative 5. That gives me negative 15, so I'm good here. All right, so this is when t equals 2.5 or 5 seconds. Okay, that's when we're at rest. The particle stops moving for just a moment at those two times, and that's the only time then that it could possibly change direction. Doesn't mean it does. Could be still moving in the same direction, but that's the only time that it might. So what we want to do then is put those two times on a number line, and we're going to test our velocity before 2.5, in between, and after, and see what we get. Do we get a positive or negative? And then does that mean we're moving to the left or the right at those times? Now we've already done this for 0. When we put 0 in, we got 150. That was a positive. Okay, so we know we have a positive velocity before 2.5 seconds. That means our particle is moving to the right to start with here. Okay, if we were to put, say, 3 into the velocity equation, we're going to get 12 times 3 squared, so that's 108 minus 270. Okay, so that's a negative 160 some, and then plus 150. That's going to give us a negative value. Okay, if we have a negative there, that means we're moving to the left from 2.5 to 5 seconds. Okay. Then if we pick something bigger than 5, let's say we put 10 in, we're going to get 1200 minus 900, that's 300, plus 150. That gives us a positive. Okay. And so we're moving to the right. So yes, indeed, we changed direction. We change direction at t equal 2.5 and 5 seconds because that's where v of t equals 0 and switches sign. And you got to have both of those. Okay, you can't just say that's where v of t equals 0. That alone doesn't tell you you changed direction, it just tells you you came to a stop. Got to have that switching sign as well. Now, what's the average velocity of the particle between 3 and 5? The average velocity is change in position over change in time. So an average velocity would be the change in position from 3 to 5 seconds. So what was my position at 5 minus my position at 3? And then to make it an average, we would divide by the time it took to do that. Okay, so I put this on the calculator. I went to y equal, I have the position function in there. And the easiest way to do this is just to go to alpha trace, pick y1, parenthesis 5. And this is going to have the calculator put 5 into that position function for us. Okay, and then I'm going to go minus alpha trace y1, parenthesis 3. Okay, if I hit enter, there's the change in position from 3 seconds to 5 seconds. It's a negative 28. And it took 2 seconds to do it. So negative 14 is our average velocity. 14 what? Doesn't say. It just says we're in seconds. It doesn't quite say what our distance. So it might be meters per second, feet per second, something like that. When is the particle's acceleration equal to 0? Well, we have an acceleration equation. So take that 24t minus 90, set it equal to 0, and we're going to get 90 divided by 24, which is 3.75 seconds. Okay, so not too bad. And then this one says, when is the particle furthest to the right from 0 to 5? So let's go back to our graph here. We said we were moving originally to the right from 0 seconds to 2.5 seconds, and then from 2.5 to 5 seconds, we're moving to the left. So if we're moving to the right until 2.5 seconds, turn, and then we head back to the left for 5 seconds, then in that interval, we were furthest to the right at the point where we turned around, when t equaled 2.5 seconds. We know that for sure. If we wanted to know where that is, we could put that into the position function and actually give a position, but they just asked for when, and so we've got the answer there.